there is one other method we can use to process the kind of the data that we just saw. It's sometimes called decision tree learning. Recall that when we were discussing case-based reasoning, we talked about discrimination tree learning. There, we learned the discrimination tree incrementally. A case would come one at a time, and we would ask the question, what feature would discriminate between the existing cases and the new case? And then we'll pick a feature. Discrimination tree learning provides no guarantee of the optimality of this tree. That is to say, at retrieval time, when a new problem comes along, traversing this tree might take a long time because this tree is not the most optimal tree for storing these cases. We'll discuss an alternative method called decision tree learning, which will give us more optimal trees, however at a cost. The cost will be that all the examples will need to be given right at the beginning. Let us return to our restaurant example. We want to learn a decision tree that will classify these 5 examples so that as a new problem comes along, we can quickly find which is the closest example to that new problem. To do this, we need to pick one of the 4 features, restaurant, meal, day, or cost, that will separate these allergic reactions so that one category contains either only false instances or only true instances. As an example, supposing we think of restaurant as being the decisive feature. So we have picked restaurant as the decisive feature. Now there are 3 kinds of restaurants, Kim's, Bob's, and Sam's. Whenever it's Kim's restaurant or Bob's restaurant, there is no allergic reaction. Whenever it is Sam's restaurant, there can be allergic reaction shown in green here or no allergic reaction shown in red. So the good thing about this particular feature, restaurant, is that it has separated all the 5 examples into 2 classes, into the class Sam's and into the class not Sam's. The not Sam class consists of only negative reactions, which is good because we know that we have now been able to classify all of these 5 examples into 2 sets, one of which contains only negative examples. Now for these 3 examples, we must pick another feature that will separate them into positive and negative instances. In this case, we might consider cost to be that feature. When the cost is cheap, then we get positive examples. When the cost is expensive, then we get negative examples. This is the classification tree, and in fact, this is a very efficient classification tree. When a new problem comes along, for example, visit 6, Sam's, lunch, Friday, cost is expensive, and we want to decide what the allergic reaction might be, we simply have to traverse through this tree to find out the closest neighbor of that particular new example. This is called a decision tree, and this technique that we just discussed is called decision tree learning. This method of inductive decision tree learning worked much more efficiently and apparently more easily than earlier methods we had discussed. But the trade-off is that we needed to know all the 5 examples right in the beginning. Of course, this technique simply appears to be efficient and easy, and that is because we had only 5 examples and only 4 features that were describing all 5 examples. If the number of examples was very large, or the number of features describing each examples were very large, then it's very hard to decide what exactly should be the feature that we should use to discriminate on.